Today we are going to understand about the push down automata for the language capital L equals to a power n b power n such that n is greater than or equals to 1. Means if we have 1a, there should be exactly 1b. If we have 2 a's, then there should be exactly 2 b's. If we have 3 a's, then exactly it should be 3 b's. So we have to design a push down automata. So if you are going to design a push down automata, number of A's we have read, definitely it should be equal to number of B's. So for this we need some data structure in order to read the number of A's, store that in the stack, and whenever we get B's it should be popped out. So Z0 will be the initial symbol present in the stack. Whenever a A's has been pushed into the stack, whenever a input symbol A has been read, it needs to be pushed into the stack. First A has been pushed, second A has been pushed, third A has been pushed. So whenever we see A's, all A's should be pushed into the stack. Whenever I read B, then definitely its corresponding symbol A should be popped out. Whenever I wanted to push B into the stack, then A should be popped out. Okay, 1A, 1B is popped out. Next, whenever I want to push the next symbol B, then A should be popped out whenever B is reached. So, whenever I insert or push input symbol B, then A should be popped out. Next, again one more B is there. Again, if I want to push the B, then A should be popped out. Okay, so in this way we can able to count the number of A's and number of B's by using the data structure called stack. Okay, so that's why we will call the automata as push down automata, pushing the elements and storing the input symbols and then reading out in the form of a linear fashion. Hence we will call this as push down automata. So generally the push down automata what we are going to design, it will be same like a finite automata. Only the thing is we have a special data structure called stack to read and store the input symbols whenever we want to keep track of the number of elements. Okay, so I have told you first the input symbol. If there are no input symbols in the stack, then there exists a stack symbol. We will call it as Z0. If we are reaching Z0 means we can tell that the stack is empty. Like a C program in data structures, we will understand if top value is -1 means the stack is empty. So in the same way, to keep track of elements in the stack, we will assume a symbol called Z0 saying that the stack is empty. So initial state will be Q0. Okay. So Q0, whenever I read input symbol A, then it should be pushed into the stack. So how to write a transition function for this? Delta Q0 is the initial state. Q0 is the initial state. What is the top of the stack? Top of the stack is Z0. So whenever I push A into the stack, whenever I push input symbol A into the stack, then what happens? It will be pushed into the stack. State remains same. So that equals to Q0 A Z0. Okay, what does this say? Z0 is the top of the stack. I am pushing the input symbol A. Then state will be same and A will be the top of the stack. Z0 above Z0 A. So it is written as A Z0. Again, any number of A's, not only 3 A's. If I have 2 A's, 3 A's, 4 A's, 5 A's, it should be just pushed into the stack. So we can write the transition function as, because the state is still Q0. Now what is top of the stack? A. So A. Now what I am pushing? The second symbol A. When A is top of the stack, if you want to push an input symbol A, then the state remains same because I have to push more input symbols. If I change the state, it will be more Q1, Q2, Q3 and so on. So same action will be performed many times. Then I can put a self loop. That is Q0, top of the stack is A and I am pushing A. So it becomes A Z0. So now I am pushing the second input symbol. Top of the stack is A. I am pushing input symbol A. Q naught is the state. It becomes Q naught A Z naught. So again third symbol A. If I am pushing A, top of the stack is A. Again it will be same. State will remain same. So with this I can push any number of A's with Q naught. Top of the stack is A and pushing A again and again. Now this string I have only 3 A's and 3 B's. I have pushed 3 A's. Right? Next, whenever I encounter input symbol B, then A should be popped out. So Q naught, if the top of the stack is A, if I push B, see here, Q naught, if the top of the stack is A, if I push the input symbol B, then the element should be popped out. Now here if you check, there is no input symbol. No input symbol means it is epsilon. So hence we will write it as Q naught BA means popped out. We will write it as Q naught comma epsilon. So it is changing. Some action is performing. Hence we will change the state to Q1. Now the state has been changed to Q1 because 1A, 1B has been matched. So change the state to Q1. Next, I am sending the second B. Second B, second A should be popped out. Now it is epsilon. So what is the transition? Now we are in state Q1. Top of the stack is A. I am pushing B. Hope you are understanding. First Q naught is the state. Top of the stack is A. If I push B, it will be popped out and state is changed to Q1. Done. This is with respect to 1A and 1B. I have more A's and more B's. The state is in Q1 now. Q1. If I push B, top of the stack is A, it should be popped out. So, same action will be performed again and again. So, the state remains same. That is Q1 comma epsilon. Now, again one more B. See here, one more B is inserting into the stack. Now top of the stack is A. So both will be popped out. See, one more B I will insert. It will be popping out. Now it is epsilon. Now still the state is in Q1 only. So Q1, one more B is inserted. A is top of the stack. It will be Q1 epsilon. So finally all the elements are popped out. The state is still in Q1. So Q1 now top of the stack is epsilon. So Q1 epsilon Z naught, that equals to reaching to final state, that is Q2 Z naught. So this is the representation of a push down automata for a language A power n, B power n. So what we are doing? First we are pushing the element A, input symbol A into the top of the stack. Top of the stack, if there are no elements, Z naught is the top of the stack, we have pushed A. So like that many number of A's we have pushed with this. So same action is repeating. So don't change the state. Next, if A is top of the stack, if I want to push B, then A will be popped out from the stack. Q naught will changes to Q1. Okay. Again same operation will be performed. Again A is top of the stack. I want to push B. So but the state has been changed to Q1. So Q1, A is top of the stack. If I push B, it will be popped out. Now it is Q1 comma epsilon. So like that many number of B's, if I push, it will be popped out and state remains same in the Q1. See here many number of A's pushed, so Q naught will be in the same state. Here many number of B's are pushed and popped out, hence it remains in the state Q1. So finally this is our transition function. So based on this, we will try to design the transition diagram. So what is the first transition? Q naught. Q naught is the state. Q naught, we have Q naught, Q1, Q2 are the states. So we will write Q naught, Q1 and Q2. So Q2 is the final state. So now first transition. What is the first transition? Q naught on A, Z naught is A. Top of the stack will be A. Going to the state Q naught. Q naught is going to the state Q naught. Top of the stack is Z naught. I am pushing A. Now it is A. Now A is the top of the stack. Next transition function. A is top of the stack. If I am pushing A, it should be, top of the stack should be A. So it is going to the same state, that is Q0. So next set is input symbol A is pushed, top of the stack is A. Now it will be A. See, A is top of the stack, I am pushing A. Now finally I am getting top of the stack as A. So that is the state. Next, A is top of the stack, I am pushing B. It should go to state Q1 epsilon. So it should go to state Q1. If A is the top of the stack, I am pushing B. So both will be popped out. Now the top of the stack is epsilon. Going to the state Q1. Next, same action. A is top of the stack and B if I am pushing. The state has been changed because one popped is done. Now again it should be same. Top of the stack is A and B if I am pushing. Same action should be performed. So Q1 will remain same. So Q1 is moving to the state Q1. A is top of the stack. If I push B, pop out epsilon. For the first time, change the state. Many times, no need to change the state. So first time, it will be the same. Many times, it will be repeated. Okay, finally, this transition. Q1 on epsilon Z0 going to Q2. So Q1, epsilon, top of the stack is Z0. It will be Z0. Epsilon, top of the stack is Z0. Top of the stack becomes Z0. So this is our transition function. That is transition diagram for the given language.